Okay, 5.4 notes. We're doing Introduction to Derivatives. This is a big lesson today. So we're going to find the slope of a curved graph at a given point. To do that, I'm going to open up this link here. It's going to open up a graph for us. So notice that when it's a line, the slope is constant on that line. It's always the same, going down 2 over 1, down 2 over 1. But if it's curved, that's not the case. So in this case, it depends on which part of the curve I'm talking about to where is the slope positive or negative on that curve. So let's say I'm trying to find the slope at this point C on the graph. I can pick a second point to help me create a line because you need 2 points to have a line, and on this line in particular, there's only the 1 point. So I need 2. So now that I have this other point, I'm going to call it point C plus a little bit more, right? So I want to get these as close as possible because I'm trying to match it to the line here. So if I connect these, I can see this is not going to match the slope. So I'm going to move this point closer, 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 closer until basically they're almost exactly the same point. Another way to word this is they're approaching a distance of 0 between the 2 points, or the limit between the 2 points is approaching 0. So we're going to talk about finding the slope of a curve using these 2 points in our lesson today. All right, so this image is trying to replicate what we saw on that graph over there before. So if you notice, I have a curved blue line. I'm trying to find the slope at point P in this case, and I'm going to use point Q to help me do that. So from point P to point Q, I want them to be close together. So notice the point P has an x value of, let's say, a. And then this is my y value, which would be f of a in this case. So it's a comma f of a. Point Q is some distance away from a. So we're going to add in a distance of h. So a plus h. Then point Q has a height of this f of a plus h on that function. And our goal is to make h 0 as much as possible, approaching 0, the distance between those 2 points. Now, if you think about how to find the slope of a line, the formula was y2 minus y1 over x2 minus x1. So this is the symbol we're going to be using to find the slope of a curved line. So it's f prime of a. And I'm using the formula y2, which is f of a plus h, minus y1, which is f of a, all over x2, which is a plus h, minus y1, which is a. So that's finding the slope between these 2 points. Notice on the top, I don't know what the function is at a plus h or a, so I can't simplify the top. But on the bottom, a minus a cancels. I'm just left with h. So this is the slope between these 2 points. Now, if I don't want it to be completely different than what it would be at point B on the curve, I want to set this to have a limit as h approaches 0 of that f of a plus h minus f of a all over h. So this is the formula we're going to use on the next couple of problems. And it'll tell you the slope at the point a comma f of a, this point right here. Okay, I know you're probably confused. Don't worry, I break things down step by step. So here we go. It says to consider the function x squared. We're going to graph x squared. That's a U-shaped graph. It's not transformed anywhere, so it's going to be at 0, 0. You're going to square the numbers from that point. So 1 squared is 1, folded over the vertex. 2 squared is up 4, folded over the vertex, and there's my U-shaped graph. Then it says to focus on the point 2 comma 4. So right 2 up 4, that's my point of interest. I'm going to find the slope that goes through that point. So that means you have to draw a tangent line, a line that's going to not touch that graph except for at 2, 4. So I'm going to do kind of a sketch here. Notice this is going through the graph at that one point. Now we're going to talk mostly about this red line for now on. The goal is to find the slope of this line and eventually the equation of that line. Notice it's just a sketch, so this could be completely wrong. So we want to use math to make it absolutely correct. So this was our equation, x squared, that we graphed. We're focusing on the point 2, 4. And we learned this is our equation to use to find the slope on a curved graph, which x squared is a curved graph. So if you recall, this is our point x, y. Well, since this is the point of interest, this is also our a value, because remember at point P on the previous problem, a was the x coordinate of the point of interest. So I'm going to take this equation and I'm going to plug in a 2 for the a value. So your x value is always your a value. So when you do this, I get the limit as h approaches 2 of f of 2 plus h minus f of 2 all over h. Sounds simple, yes? Well, I know we learned that to find the limit, you can just plug in 0 for h and be done. But notice if I plug in 0 for h, I'm going to be dividing by 0, which that's not allowed. So I cannot start this by plugging in the zeros. I have to instead simplify the top and then see what divides out. So I'm going to go ahead, drop down the limit as h approaches 0 since I can't plug it in. And then I'm going to evaluate this f of 2 plus h. This is going to get plugged into our graph. So if you plug in 2 plus h into x, it's going to become 2 plus h squared. Then I have a minus. Then I have f of 2. That means I'm going to plug the 2 into the function, which will become 2 squared. And again, this is all over h. Still can't plug in the 0 for h because I'll be dividing by 0. But notice I have to square this 2 plus h. You can do this by doing FOIL. You can do this by doing the box method, which is what I end up doing over here. I'm multiplying 2 plus h times 2 plus h. So 2 times 2 is 4. 2 times h is 2h. H times 2, the number goes first, so that's 2h. And then h times h is h squared. I have to simplify this. So I'm going to write it in standard form. The exponent goes first, so that's h squared. 2h plus 2h becomes 4h, and then plus 4. So again, what am I doing? This is this 2 plus h squared. So I'm going to plug this in for this part of the equation. So h squared plus 4h plus 4. Then I have a minus 2 squared, which is 4. And again, this is all over h. Now, if you notice, on the top, I have a plus 4 and a minus 4. Plus 4 minus 4 cancels. And then if you notice here, I can divide both of the terms by h. You'll know you did this part properly if whatever is left after you cross off what cancels is divisible by h. So that's going to be my next step. I can't plug in the 0 yet, so I'm going to drop down the limit as h approaches 0. And then I'm going to divide both of these terms by h. So h squared divided by h is h. And then 4h divided by h is 4. Notice the h is gone on the bottom. Now I can finally plug in the 0 for h. And notice that leaves me with 0 plus 4, which is 4. Okay, so what the heck is 4, right? Remember what we were trying to find. We're trying to find the slope of the curved graph at that point 2, 4. So going back to this graph, the slope of this line we just found out is 4 at this point 2, 4. So then in part B, it says to write the slope-intercept form of the tangent line. So remember back in Algebra 1, you learned about y equals mx plus b. we have learned that the slope was 4 using our equation. And then I'm going to use this point where x is 2 and y is 4, and I'm going to solve for b. So we have a y value of 4. Our slope from part A was 4. Our x value is 2, and I'm solving for b. So I'm going to simplify. So this is 4 equals 8 plus b. To get b by itself, I have to subtract the 8 over. I'm going to get negative 4. So then the equation of the line, we had a slope of 4 and I have a y-intercept of negative 4. I'm plugging both the slope and the y-intercept in. So the equation is y equals 4x minus 4, where 4 was the slope and negative 4 is your y-intercept. So what did I just find? I found the equation of this red line. I found the slope and I found the y-intercept of that line that goes through this point on this curved graph. Alrighty, let's try another one. So we have the equation, we have our point, so we're going to plug in our point into the formula. Remember, your x value is always your a value, so we're going to plug in a 6 for a. So it's the limit as h approaches 0 of f of 6 plus h minus f of 6 all over h. So we can't plug in the 0. We're going to drop down the limit. And now we're going to evaluate the top. So we're going to plug in 6 plus h into the function. So that's going to give me 7 times 6 plus h and then minus 1. And I'm going to put little brackets around there so I'm keeping track that this was plugging in the function for the first part. Then we have a minus. Now I have to plug 6 into the function. So that's going to give me 7 times 6 minus 1. And I'm subtracting all of that. So I'm going to put brackets around that so I remember I'm subtracting this whole thing. And again, that's all over h. So drop down the limit. We have to distribute. So 7 times 6 is 42. 7 times h is 7h minus 1. Then we have minus. Then I can simplify over here. 7 times 6 is 42. 42 minus 1 is 41. And that's all over h. Notice on the tops, I have 42 minus 1 minus 41, which that then would cancel. These go away. So now I'm taking the limit as h approaches 0 of 7h divided by h. Notice the h's divide out. I'm just left with 7. Notice I can't plug in the 0 for h because there are no more h's. So we have to remember the limit as h approaches 0 of a constant is that constant. So that's just 7. Again, this was the slope at that point, 6, 41. Now, not to get too mad at me, if you look, this was a line. And hey, the slope of that line was 7. Kind of cool when that actually is proven in a different way than you are used to seeing. All right, so imagine having to do all of this work at a different point on the line. So imagine I change the point to like 1 something. You would have to go through all of this again and again and again with a new x value. There has to be an easier way. Okay, so the easier way is called the derivative. So this is an equation you can use to find the slope at any given point of a curved line. Notice this looks remarkably similar to the one we were using before. The only difference is instead of the letter a for whatever point I'm giving you, we're going to keep it the variable x. That way it'll work for any point. So we're going to dive in and find the derivative of this function. So knowing our derivative formula, we're going to start plugging this in, which is kind of awful looking because notice there's not very many numbers left and we can't even use the one that we do have, the 0. We can't even plug that in. So we're just going to drop this down and then I'm left with this. This is going to get plugged into f of x. So this is going into the x values up here. So it's going to become x plus h squared. And then plus plugging it in for this x, another x plus h. And again, I'm doing square brackets around that to keep that together in my head. And then the formula says minus, and now I'm plugging in x for x. Notice that's not really going to change anything, right? Another way to think of this is you're subtracting the function f of x, and this is f of x. So two ways to think of it, plugging in x for x or subtracting all of f of x. Okay, so once we have our top, we can say this is all over h. Dropping down the limit. Notice I have to square x plus h. So I'm going to go ahead and do the box method again. X plus h times x plus h. All right, so using this, we go x times x, which is x squared. We're doing x times h. I'm going to go ahead and do it alphabetical and call it hx. H times x is, again, alphabetical hx, and then h times h is h squared. So if I simplify this, I have x squared, plus I have two hx's, and then I have an h squared. So this whole thing was squaring this x plus h. So that'll go in right there. And then I can drop this down, this plus x plus h. And then I'm going to distribute this negative to go negative x squared and a negative x. This is all over h. So from here, I can start crossing things out. So notice I have this minus x squared. That'll cancel the positive x squared. And the minus x will cancel the plus x. Notice all of the remaining terms on top are divisible by h. That's how you know you did this correctly. So 2hx divided by h. The h's cancel. I'm left with 2x. Plus h squared divided by h is just h. Plus h divided by h is 1. Now that I have divided by h, I can plug in 0 for h. That'll leave me with a 2x plus 0 plus 1, which is just 2x plus 1. So again, after you do the derivative, what you just found was the slope. But this isn't just the slope at a single point. This is the slope at any single point on this graph, which is pretty cool because then I can give you any point I want, say x is 5, and then quickly say, okay, well, the slope would be 11 where x is 5. Or I could do like -2 and plug in that, and I can find the slope after slope after slope. Instead of doing that a formula, which would have to be done each time, this works for any point. Pretty cool. So then in part B, I'm going to go ahead and give you the point now of -2 and 2. So that's going to be our x and our y. And then we have, this was our equation for our slope. So we're going to plug in x to find our slope. So we have 2 times 2 plus 1. That would be -4 plus 1, which is -3. So that's our slope. Now that I have m, x, and y, I can solve for b. So I'm going to get y equals 2, plug that in. The slope was -3. My x value is -2, and I'm solving for b. So this gives me 2 equals +6 plus b. And then I have to get b by itself by subtracting the 6 over, and I'm going to get -4. So there's my m, there's my b. So my equation is y equals -3x minus 4. And then I went ahead and graphed this. And so this red one is the curve that we were finding the derivative of. And then this is our tangent line at the point of interest, -2, 2. And notice that is the equation of that tangent line. All right, number 4, finding the derivative of this equation here. So the first thing you should do is use that formula, write it down so we can start plugging things in. So then drop down the limit as h approaches 0. This x plus h is going to get plugged into the function f of x. So the x's are going to go away and become x plus h. So this is going to give me x plus h squared minus 4 times x plus h plus 2. So that's me plugging in x plus h to the function. Then we do minus. Now I have to subtract all of f of x. Or you could think of it as plugging in x for x. So if I'm subtracting this, I get minus the quantity, using the brackets here, x squared minus 4x plus 2. And this is all over h. So we can drop down our limit. Hey, look, I already squared x plus h. I've already done this work, so I don't have to do it again. So I can just say that this is equal to x squared plus 2hx plus h squared. So plugging that in for this part. Then I have to distribute the force. So negative 4 times x is a negative 4x, and a negative 4 times h is a negative 4h, and this is a plus 2 on the end. Then I have to distribute the negative over here, so that'll become a negative x squared plus 4x and a minus 2. That way you're subtracting all of f of x. And this is all over h. So then I can look to see what cancels. So I have a negative x squared that's going to cancel the positive x squared. I have 4x that cancels the negative 4x. And I have a negative 2 that cancels the positive 2. Notice all of the terms that remain can be divisible by h. That's how you know you did this correctly. So this 2hx divided by h is just 2x. H squared divided by h is just h. And negative 4h divided by h is negative 4. Now that you've divided everything by h, I can plug in 0 for h, giving me 2x plus 0 minus 4, which is just 2x minus 4. So that's our equation to find the slope at any given point. So in part B, we're supposed to find the slope at this point. So that means I'm plugging in the x value on my point. So it's 2 times 2 minus 4. That'll get me 0. So the slope at this point is 0. And notice it's not telling us to find the equation of the line, it just says to find the slope. So we're done. Here's a picture just to show you this is the equation of the graph. And notice this 2, negative 2 was the vertex, which is why the slope is 0 at that point.